Okay, so today we're talking about some more triangle congruent stuff. So yesterday we mentioned that for two triangles to be congruent, all three of the angles have to be congruent to all three of these angles. And then all three of the sides have to be congruent to each other. So like AB and DE, AC and DF, and BC and EF have to be congruent to each other. So we had 6 pairs of congruent or corresponding parts. And then after getting all those things, we could say that triangle ABC is congruent to triangle DEF. So today, I'm going to give you some shortcuts. I'm going to give you 2 little shortcuts. So instead of finding all 6 of those pairs, we're only going to have to find half. We're only going to have to find 3 things. So by the end of today's lesson, you'll know what SSS and SAS mean and how to use them. So the first thing we're going to talk about is the side postulate. So SSS, side. So that's just saying if I know that I have 3 sides, so GH and PQ are congruent, and then HF and QR are congruent, and then GF and PR are congruent. I know that all 3 sides are congruent to all 3 sides over here. I do not have to find the angles, because if all 3 sides of a triangle are the same length, then that means all the angles are going to be the same. So those 2 shapes are congruent. So in example 1, when I need to prove that triangle PQW is congruent to triangle TSW, I'm going to try to use the side postulate. So angle PQ, or excuse me, side PQ, is congruent to side TS. And then PW is congruent to TW. And QW is congruent to SW. So now I know all 3 sides of QPW are congruent to all 3 sides of STW. So that means that triangle PQW is congruent to triangle TSW by the side postulate. And that's it for example 1. So moving on to example 2, this time I got to prove that these 2 triangles are congruent to each other. So this is a little bit more complicated. So I recommend that you pause the video right here and see if you can do it on your own. So we know that, let's use a different color, JG is congruent to LH. So it's important to notice that I am trying to prove, so we got a lot of little 1 tick marks here. But I'm trying to look at so this is the shortest side of this triangle. My other triangle, this is the shortest side. So I'm trying to prove that those 2 sides are congruent. I don't really care about this side and this side. I only want to know about this and this. So JG is congruent to LH. This one has 2, so it's a little bit easier to see. So I know that JH is congruent to LK. So that's 2 sides. So I just need 1 more. And then finally, let's use gray. Notice that this longest side right here, this hypotenuse, if this was a 90-degree angle. So this side right here has 2 equal sides. These 2 are congruent to each other. This also has those 2 congruent sides, or 2 tick marks. So that means that GH has to be congruent to HK, because each one has the 2 little tick marks. So that means those are the same length. So now we do have three sides that are all congruent. So I know that triangle GJH is congruent to triangle HLK by the side postulate. Moving on to the next page. So we talked about the side postulate, or SSS. Now we're going to talk about the side postulate, or SAS. So this one means that we have two sides that are congruent to two sides, and then an angle in between those two sides is congruent. So, or the way they say it, two sides and then the included angle. So the angle in between those. So for example, I know that BC is congruent to FD. I also know that CA is congruent to DE. And then angle C is congruent to angle D. So notice that this angle, angle C, is in between the red and the blue sides. And angle D up here is in between the red and the blue sides. So side, angle, side, side, angle, side. So in example 3, we got to prove that triangle AEB is congruent to triangle DEC. So I'm going to take what they give me. So side BE is congruent to side CE. Side AE is congruent to side DE. Now, maybe some of you are thinking, well, I don't know what to do now because they just gave me two sides. Well, remember, whenever we have two lines crossing each other, so we got a line here and a line here, kind of missed there, but the two angles on the opposite side of crossing lines are called vertical angles. So those two angles have to be congruent because of vertical angles. So I know that angle BEA is congruent to angle CED. So notice we have a side is congruent to a side is congruent to a side, and then the angle in between those two sides is congruent. So I can say well, this is my reason, but triangle AEB is congruent to triangle DEC by the SAS postulate. So remember, the A is in between the S and the S. So the angle should be in between the S and the S, side, angle, side. And then angle 4. So I would recommend you guys pause the video and try this on your own. So I know that DA is congruent to GA. This one is a little tricky. So we got a side that is being shared by the two different triangles. So this triangle uses this red side, this triangle uses this red side. It's the same length for each triangle because it's a shared side. So RA is congruent to RA. And that's true by the reflexive property, which is something we'll learn later. This is a 90-degree angle right here. These two angles, so right here and right here, are supplementary because they form a linear pair. They're on the same line. So remember, this is a 180-degree angle. So if this is 90, this one has to also be 90. So that means that angle DAR is congruent to angle GAR. So I can say that triangle DRA is congruent to triangle GRA by the side angle side postulate, because we got a side and then the angle in between. And then angle 5, or example 5, we got to prove that these two triangles are congruent. So again, I'm going to start by writing what I know. So SP is congruent to TP and then angle SPQ is congruent to angle TPQ. So I got a side, got an angle. Again, this side is being shared by both triangles. So I know that this side is going to be the same length for this triangle as it is for this triangle. So I can say that PQ is congruent to PQ. So I got a side, angle, side. So notice that angle is right in between the purple and the blue. So I could say that triangle PSQ is congruent to triangle PTQ by the side angle side postulate.